Why do organic chemists use line angle structures as opposed to Lewis structures? The main reason is because they convey more information than something that's sort of a hybrid between a line angle structure and a Lewis structure. This is getting closer to a Lewis structure, but isn't to a Lewis structure yet. This molecule, this relatively beautiful molecule, is something that I was working on in graduate school. I was trying to make this. I never actually got there for long and complicated reasons, but this right here is the target that I was aiming for. This is what I was trying to make, and there's a lot of crazy features about it. Each one of these wedges and dashes that you see scattered throughout there conveys information. The methyl group is either pointed toward you or back away from you, and there's a bunch of different oxygens involved, and there's lots of stereochemistry. All sorts of things that we try to represent with this sort of three-dimensional kind of drawing with wedges and dashes and stuff like that. So if I'm trying to represent that molecule for you, it becomes vastly more difficult to do that if I have to draw out all of the hydrogens. It's much more straightforward if I get to ignore all of the hydrogens that aren't really important, so that I can focus your attention on the things that are, that the methyl is toward you or back away, and you don't have to pay attention to what the hydrogen is doing because it's just implied to be in the other spot. So if in particular you're looking at these two areas, you notice that this is a much cleaner way of representing the exact same information that's contained right there, and it gets even worse when you're dealing with lots of hydrogens and so on and so forth. And keep in mind, of course, that this isn't even a Lewis structure yet. For this to be a Lewis structure, I would need to represent each of these carbons with an actual C as opposed to just leaving the vertex B. Even the vertex is kind of a quick notation thing. I have decided not to even draw the thing that's up here, so I just drew this weird smear. But, you would also need to draw out the lone pairs. And of course, I don't need to do that for the same reasons that I don't need to draw out the explicit hydrogens. They are assumed to be there. Notice, of course, that whenever you're generating a line angle structure, that there are some hydrogens you always explicitly draw out. And that is basically anything that's bound to an oxygen or a nitrogen. Those you explicitly draw out. So OHs, NHs, things like that, you would always explicitly draw out. But you're going to want to get very familiar with thinking in these terms rather than these. This way of representing a molecule is really tough to look at. This way is not yet easy for you to look at, but over time you will be becoming more appreciative of the amount of information that can be conveyed simply like that, and how actually adding in that extra information makes this much harder to look at and much tougher to work with. Having said that, until you're good at the skill of working with line angle structures, you're going to have trouble remembering that there's actually a hydrogen bound at this position, and it's in the opposite direction of where the methyl is. This carbon right there has 4 things bound, so there's no hydrogens and so on. So you're not going to be good at immediately translating this in your head to the structure that's represented by it. But you have to work at this skill because this conveys so much more information. Now, why am I taking the time to digress a little bit here? Well, because if you're working on mechanistic problems later in the course, keep in mind that you are going to be relatively bad at remembering where those explicit hydrogens are and the implicit hydrogens are. So it is useful from time to time to say, explicitly I should draw this one out. Or likewise, if you're going to be doing a mechanism and it involves thinking about the lone pairs, it is worth your while to explicitly draw out those lone pairs. So normally I wouldn't bother drawing the lone pairs, but if I'm doing a mechanistic problem, one in which one of these oxygens needs to bind to, say, a new proton, and we're going to do an acid-base bit of chemistry or something, then it's useful to draw out the lone pairs to get me to focus my attention on the spots that have them and ignore the spots that don't. So anyway, you're going to be working with line angle structures extensively. Develop the skill now. You will use it constantly. You will completely move away from using this, if only because it's so much faster to draw this way than that way. Having said that, if you're ever stuck on a problem mechanistically, one of the best things you can do, draw out explicit lone pairs. And alternatively, if you're having any kind of trouble that could be resolved by drawing out explicit hydrogens, that could be a valuable exercise as well. It's almost always good to have that be a methyl rather than drawing them out, but you could draw it out as a CH3 as follows, or alternatively, there are times when it's even handier to draw them out explicitly in this way. Having said that, most of the time, you're better off representing a methyl group either in that condensed form or perhaps in this sort of condensed form, one where all of the hydrogens, if they're explicitly drawn, are not necessarily drawn out because, again, this takes up too much room. Work on developing those line angle structure skills. You will not be wanting to represent molecules in standard Lewis dot structure form from now on.